Good afternoon, y'all. Here's the warm-up. Good afternoon, everybody. I'm busy admitting people, so just again, as before, at 1:05, I'll unmute everybody. Now I'm recording this, so if there's background noise, I might have to mute everybody. The recording I did yesterday, I was listening to it on YouTube just to check it, and it wasn't as good as I liked. Okay, so you guys get to represent this lesson. Okay, so again, just like previously, at 1:05, I'll unmute everybody and begin to go over the warm-up. That way we give enough people a chance to get here. All right, good afternoon, everybody. So we got another maybe 3 minutes, and then I'll unmute everybody. So I just want to give everybody enough chance to get here. So same format as previously. I got that, Ellen. I remember you were talking about your mom's name, Anessa. Yes, Mason, and I'll probably repeat this when I unmute everybody. Email me the warm-up and the homework. Email me to Gmail. All right, Summer, glad you can make it. All right, so about another 2 or so minutes, and I'll unmute everybody. Right now, this is the warm-up. Okay, so probably another minute. Okay, so I'm gonna unmute y'all. just keep in mind I'm recording this. I'm going to post this on my YouTube channel. Is the one I posted for this lesson from yesterday. I didn't like the way the sound was. So I might have to mute y'all if it's getting feedback, okay? How's everybody doing?
I'm tired.
Oh God, it's not even an hour after.
No, I went to bed at like 2 o'clock in the morning.
That makes sense. Well, all of our clocks are off.
How are you, Mr. Napoli?
I'm all right, honestly.
Good.
This week started, I was a little, but I feel better now. I hope y'all are doing okay. So just to let you know, just to make sure everyone understands, these are going to be Tuesday to Friday, okay? And our class is going to be at 1 o'clock. And all I'm expecting is the warm-up and the homework. And so you just take a picture and send it to me on Gmail, okay? So just to make sure everyone is on the same page, all right? All right, I'm gonna go over the warm-up, and I have my cell phone with me, which I will also use since some of us might have came in a little late, so that way you can kind of see the problems, all right? Right now my screen is cluttered, so just bear with me. I got a second monitor that next week I'm gonna hook up so I can that way have something over there, and it'll be a lot easier to manage this. So I can't really see you.
I want to put you for 70 minutes. You get it back.
Okay, so here's the first problem. So hopefully y'all remember how to do these, right? So those first 3 percentage basic problems, and then we had the, come on, Napoli, there you go. And then we had the percentage of increase and decrease problems. Okay, so this first one is 65 is what percent out of 80? Right. So 5 out of 80 is what percent, right? And so you can go ahead and divide, and you would get 0.8125, right? So then if you want, you can do the shortcut, just move the decimal 2 places. But remember what this means. When you divide, you get it per 1. And so this is now your problem. So if you multiply 100, right? So 81.25%. All right, now the second one, right? The second one was 10 is 5% of what number, right? So 10 equals 5%, 0.05 of what number, right? So notice doing the shortcuts now, okay? Did anybody get that? Anybody want to take a guess what that is?
Wait, can you explain it one more time?
Okay, so you see how you have the 10 is, so that's why I wrote 10 equals. And then you see how you have the 5% of what number? So that's why I put the 0.05 times the x. Okay. Good. All right, so in divide, I'm glad you guys asked. Just shoot it out or correct, Sam. So you divide and you get 200. Okay, now number three, we got what number is 15% of 250? Sorry about that, y'all. It's the white balance. Okay. Oh, actually, no, that's my cell phone. Okay, so what number is 5% of 250? Okay, so what number, x, equals 15%, so 0.15, and then of 250. So you just solved that. Okay. Did anybody get that answer? Okay, just wait a couple more seconds. That is correct, Sam. 37.5. Okay, now the last 3 problems were based upon percentage of increase and decrease, right? So the number 4 problem, you're going to get a 12% discount on a stereo that normally costs $120, right? Okay, so we're going to subtract, because it's a discount, and we're going to subtract from the 120 based upon 12%. Right, so number 4 120, and then minus 0.12 times 120. So we can do that. All right. Now in chapter 6 in the beginning of the semester, you might remember using the growth factor. So we could do this another way. We could go 1 minus 0.12, get our growth factor, and then 120. Now in this case, this is actually a decay factor because it's subtraction. But a lot of people, including me, say growth factor for everything. All right. You get 0.88. Right? So we could do this. Now, if you understand what's going on, if you take away 12%, you're going to have 88% left. So you could go straight to here if you understand that. If you take,
Oh,
right?
yeah, now I get it.
Cool, I'm glad to hear that. Okay, so now we got 5, right? So 5, before tax, the car was $15,000. What is the price after including an 8.75% tax, right? So what we're going to do is add, because when you pay a tax, you pay more. And we're going to add based upon the 8.75. All right. So before tax, we got 15,000. And then we're going to add, so 0.0875, and the percent decimal that we multiplied to the 15,000. All right, so you can do that, but we could also use a growth factor, right? So since this is plus, you go 1 plus 0.0875. Again, that was what we were looking in chapter 6 in the beginning of this semester. And then it doesn't matter where you put the 15,000. You could put that here if you want. And then that'll get you the answer. All right, did anybody get that answer? Okay, I'll wait a couple seconds. Okay, well, if you want to check yourself, it should be 16,312.5. And bingo, Sam, you're correct all 3 times. You're on a roll. Okay, so now 6, you can see that the revenue in, hold on, I'm in the middle of doing something, y'all. I got sidetracked. All right, okay, I can't do 2 things at once. Let me leave that alone. So, yeah, in 2015, you originally had $400,000. And then in 2016, the revenue increased to $450,000. What's the percentage of increase? Okay, so this is where you do the new minus the originals. Right, let me see if I can do this. So that's the new, and then that's the original. Okay, so 450,000 minus 400, and then based on the original, so we divide this by 400,000, and then that's the percent that we're looking for. So we solve that. All right, so that's where that comes from. Okay, now this is an increase of 50,000. So revenue went up 50,000 in here. So that's just yeah. Okay. I have to mute this, y'all, because the noise continues. Thanks for that. So here we would divide, and then when you divide, you should get 12.5%. Okay? Everybody good? Okay, so we're going to go over the homework, and I'm going to assume homework issues, but feel free to let me know if I skip something. So here's the solutions for the homework, and just like before, I shared this with you, so you guys have access to this. All right, I might have even posted it on today's link, but so you have access to this. Okay, so when we're looking at the homework, which would be these problems. Okay. All right, so now the first one I thought was tricky was number 6. Okay, and that was because number 6, they wanted you to find the mean weight of the combined number of computers, right? So they tell you the mean of 5, and they, wait, what am I looking? I'm looking at 6. I'm looking at 7, sorry, my bad, I'm sorry. I was reading number 6. Number 7, you got the mean width of the 12 iPads is 5.1, and you got the mean width of the 8 Kindles is 4.8, right? And so if we want to find A and B, we want to find the total width of all the iPads. Well, there's 12 of them, so we multiplied the 12 to the mean. And the same thing with B. We want to find the total width of the Kindles, and there's 8 of them, so that's why we multiply the 8 to the mean. Okay, so now we got the total width of the iPads, and we got the total width of the Kindles. If we want to get the total width of them combined, we would add the two totals. And since there's 12 plus 8 items, that's why we divide by 20. And that gets us the mean for part C. Okay, and then the next one I thought was a little tricky was this one. And this one is the information they give you, right? So they don't give you the raw data. They just give you the intervals. And so we know that the weight of these computers, there was 8 of them between 3 and 5 pounds. 5 and 7, between 7 and 9, there was 45. Between 9 and 11, there was 18. And between 11 and 13 pounds, there were 4 computers. So this is the number of computers that occurred within each of these weight intervals. Now, the problem with this, if we're going to find the mean, we don't have the numbers to add up. We just know how many occurred in each of these intervals. So what we got to do is we got to get a single number to represent these intervals. And the fairest number is the number in the middle, right? So in between 3 and 5 is 4, in between 5 and 7 is 6, in between 7 and 9 is 8, in between 9 and 11 is 10, in between 11 and 13 is 12. So each of these numbers in the middle, those are called the midpoints, right? So now we have a number to associate. So now we can just multiply 4 times 8, 6 times 25, 8 times 45, 10 times 18, 12 times 4. Add those up. And then you can divide by 100 because there's 100 computers. Now they told you that, but if you added up the number of computers here, that sum would be 100. So you could have found it that way as well, but they told you that there was 100 computers. Okay? All right. Now the reason we learned that formula is that we can find the median if we know the value, but if all we know is the position, then we have to use the n plus 1. Notice 11, you can find the middle of the numbers once you put them in rank by looking. But for 12, you wanted to find the middle of the 23 seats. So how are you going to be 23 seats? What's the middle? Okay, so 23 plus 1 divided by 2. 23 plus 1 divided by 2 is 24 divided by 2, which is 12. So the middle is the 12th seat. And Joe, I'm not offended, but you really should be more polite. You can just say, I am leaving. You don't need the attitude, right? I understand this is hard on you. Don't take it personally. Okay, so number 14. Number 14, we want to find which one of these 4 choices, okay, is correct. The only thing we know is that they all start with 32. Which one of these is going to have a median of 35? All right, well, it would have to be C because it's the only one that has a median of 35, right? So this median would be 34 for A. This would have been 36.5 for B, and then D would have been 38. So C. All right, and then notice that 15 is kind of tough because you had to rank all those 30 numbers. Today we're going to learn a quick way to organize the numbers, but once you did that, 30 plus 1 divided by 2, in between the 15th and 16th number, that would be the median. All right, 16 and 17 might have been hard for y'all because you had two words that you didn't know. Quantitative data is data that's numerical. So that would be like your height. That would be like the amount of money in your bank account. Values that are numerical. All right. So with numerical data, you can find a mean because you can add the numbers and divide by however many. You can find the middle number because you can put the numbers in order. And you can have the most frequent number, so you can have a mode. All right, 17 is qualitative data. Now, qualitative data, like quality, is based on characteristics that are not numerical by nature. So the color of your hair, right? The color of your car. These are not numerical. So we can't add numbers and divide by anything. So we can't find a mean. And how do you put your color of your hair in order? So there's no inherent middle, so no median, but there can be a most frequent color. So we can have a mode. Okay, and we're almost done with this. And so 18, if you only have one mode, then unimodal, like a unicycle, one wheel, right? And you can see what I did to find the modes for the last stuff here. And this is what we're going to look at today. This is called a frequency table. And these are called tally marks. And so there were two modes for 22. So that's bimodal, like bicycle, two wheels. Okay, and then you can see same thing here and the same thing over here. Okay, and anybody got any questions about this? Okay. When I get my second monitor, I'll be able to be a little more flexible with the video, but I'm just not set up for that right now. So work in progress. We're all learning, right? Let me get to the stem and leaf plot. Is a very helpful way to organize numbers, right? So when you had those 30 numbers, that took a little while to organize, right? This is a way of quickly organizing numbers, and this symbol right here symbolically is telling you how to do that, right? It's telling you on the left of the vertical line is going to be 4, which is the tens place, and on the right of the vertical line is going to be 5, which is the ones place. So it often will just show it to you like this. This is me just being helpful. You don't usually see that. You just see this. Okay, so we're going to organize these numbers. All right, when we look at these numbers, since we're organizing them by tens place and ones place, we notice that we have no single digit numbers and you have no 3-digit numbers. So we're going from 10 all the way to 90. Okay, and where is my pen? I just had it. Okay. All right, so now I'm going to stop the screen share. And we're going to look at these numbers. Okay, so when we do the stem and leaf plot, we're going to put the tens place digits, starting with 1 and going all the way down to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then we're going to put on the left, oh, sorry, my bad. On the right, we're going to put the ones digits. So the first two numbers are 94, 91, and then 23, right? So 94, 91, and then 23. So notice I just put the 1. So this means you got 94 and 91, and this means you got 23. Okay, so the next three numbers, 56, 46, and 76. So 56, 46, and 76. Okay, and then we got 13, and then we got 40, and then 99, and then 28, and then 81, and then 95, and then 29, and then 43, and then 10. Okay? And so notice you're only putting a single digit on the right. You're just putting the ones place. And so now notice how you can quickly organize these numbers. This you can do really quickly. And then, okay, so 10, 13, 23, 28, 29, 40, 43, 46, 56, 76, 81, 91, 94, 95, 99. Okay? Anybody have any issues with that? Okay, these are called the leaves. And this is the stem. All right. So, Sienna, what did you miss? Oh, geez. Okay. So I just organized these numbers, all right, based upon tens places. So we went from tens to the 90s. And so on the left side, I wrote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10s are going to go here, the 20s there, the 30s there, 40s, the 50s, 60s, 70s, 80s, 90s. All right, so hold on, my phone just shut off. All right, so the first two numbers there, oops, were 94 and 91, and then there was a 23. So I wrote 4, 1, and then I wrote 3. Right, and so then you just keep doing that with the rest of the numbers. So you just write the ones places. Sorry, it's kind of hard to get this because it's backwards. I'd like to hope I get the hang of this. Yeah, there you go. Okay, so 56, and then you got 46 and 76. So that's what, 56, 46, and 76. Right, so this means 10, 13, 23, 28, 29, 46, 40, 43, 56, 76, 81. This means 94, 91, 99, 95. Is that okay? Cool. All right, y'all, so we got one more thing to do. All right, this is useful when you have to organize a lot of numbers. Okay, that's the only thing this is used for. It can also give you kind of a sense of where the numbers are grouping. So you can see there's a lot of numbers here in the 90s, and there's a whole bunch of numbers here in the 10s and 20s. So it can help you that way too. All right, so I'm gonna go ahead and share my screen. And so now we're gonna do what's called a frequency table. All right, and what this data represents is the gas mileage per person in each state for the entire month on average. And this came from the Department of Transportation in the year 2000. So on average, this is the miles that people drive per month in each of these states. Now, it might be a particular month, but I can't remember. Obviously, this is a long time ago. All right, so if we want to organize this data, we got to figure out how to make our groups, how to make our intervals. All right, so in order to do that, we got to find the largest and the smallest number. Okay, anybody see the largest number? Okay, I got 10 as C, TN. So let's have more eyeballs on this, make sure I'm right. Okay, so TN, Terra Nova, right? Of course, we're the best. So 5865.58. So that's the largest number of miles per month for any state in the United States. What about the smallest? Anybody see what the smallest is? Okay, I got North Carolina, which kind of surprised me because North Carolina is pretty big. You know, it's got a whole less number of miles per month on average. And you look at Vermont, Vermont's tiny, right? Rhode Island, it's extremely tiny. And I think this is probably, there's a lot of poor people. It's a huge farming community with a lot of pig processing plants, and the people who work there are poor. So they don't have cars. They live next to where they work, and that's it. Speculation, but it's pretty an educated guess. All right, so we're going to take that, and we're going to subtract from the large value. All right, so I'm going to stop sharing the screen now. Okay, anybody get what that is when you subtract these two? Did anybody get that? Okay, I'm doing it myself. Yes, that is called the range. When you subtract the highest and the smallest data value, you get what's called the range of the data. It's not the same as the range of a function. So it's the width of the data. That is correct, Ellen. It is 259.92. Okay, so this is the span of numerical value that we gotta, I can't do that with my hands, assess, right? So how many categories do we use? 8, 6? Let's go ahead and use 10. So we'll divide this by 10. All right. And let me make sure I didn't do anything stupid. Yeah, so this is 25.992. Okay, so we have to have at least this much width if we want to cover the smallest value and the largest value in the set. All right, so we can't round down because then we're going to go not far enough to get this. We might land at 554. All right, so we'll have to create an 11th category. So let's round up to the nearest multiple of 5, which would be 30. Okay, so we're going to make each category a width of 30. We're going to start with the bottom number and go up to the top. All right, now let's be practical. So we're just organizing data here, so it doesn't have to be exceptionally precise. Let's go ahead and start at 290. That way it's easy to add 30. Okay, so I'm going to start with the 290, again, just rounding down to this multiple of 10 to make this easier. And since we want each category to have a width of 30, let's go ahead and add 30 all the way down. Okay, so I'm adding 30. So this is 320, 350, 380, 410, 440, 470, 500, 530, 560, and now we're okay, we got enough. But since this is the last number and we want a width of 30, let's put the 560 as the second number in the last category. So this category, we're going to count all the numbers starting with 530 and ending with 560. Okay, now we're going to go back up and start creating the second numbers for the other intervals. Well, since this last interval, the smallest number was 530, then the interval above, the biggest number would have been 529. Right? Notice I'm just going back by 1. So this second to last interval is going to be the numbers from 500 to 529. All right, so the third to last interval, since this is 500, the second number for this third to last interval would be 499. Right, so you just go back by 1 from the previous first number. So 469. All right, so this would be 439. Okay, and then this would be 409. And then this would be 379, right? And 349. And then 320, so one less than 320 is 319. Okay? And so now we got our intervals. And there's 10 of them. Now, if we wanted to, we could just pick some arbitrary interval. We could just say, well, let's just go by 50s. You could do that. If you want to start at 200 instead of 290 or 250, okay? But if you do that, you're just picking a number out of your head. And so somebody might ask you to justify this choice, and you could just say, hey, wait, I just took the largest and smallest and then divided by 10 and rounded up to the nearest multiple of 10. So that way you can defend this. It's not biased. And so that's why we're being more mathematical with it. Does anybody need help understanding how to create these intervals? Okay, we're almost done. And so now we got to organize the numbers. Okay, so I'm going back to the data. So we're going to do these first three. And then, once I do a couple here, I think you'll get the idea, right? We don't need to do all 50 states, right? So we got Alabama, so 544. So I'm going to put, for 544, that's in between 530 and 560. So I'm going to put a tally mark. And then we got 433. Okay, well, that's in between 410 and 439. So I'm going to put a tally mark there. And we got 452. That's in between 440 and 469. So I'm going to put a tally mark there. 432. That's in between 530 and 560. Another tally mark, and I'll finish up with California. 422. Okay, so we're going to put a tally mark between 410 and 439. Okay, and so this is what that looks like. And so then you just do the same thing for the other 50 states. Is everybody okay with that? Anybody want to ask anything? All right, I got one more point I want to make. I'm just going to wait a couple more seconds. Now, when you get to 5, you do that. And the reason why people do that is because human beings, we have a hard time dealing with anything more than 5. And people say that it's because of 5 fingers. So paying attention to more than 5 numbers, most human beings are going to have trouble with that. For instance, can you tell how many there are? How many tally marks are there? You can't tell immediately, right? Because this is overwhelming your senses. You're trying to pay attention to more than 5 things. Okay, well, I'll tell you there's 13. But if it was written this way, you can immediately tell that's 13. And here you might miscount. So that's why people do that. And these are called tally marks. It tripped you out, huh, Jalen? Okay, y'all, so anything anybody needs beyond this? Okay, so you got the homework, which is, it's not a lot. It's like maybe, I think, 3 problems that involve some of this. If there's anything you need, just shoot me an email. I'm developing a habit of not looking at my emails until after 2, though, just so you know. So after I'm finished here, I'll probably eat something, and then I'll go look at the emails and respond. You too, Jalen. Okay, y'all, I'm going to go ahead and leave. Y'all have a great weekend. Stay safe.